and flip to page 36. I want you to take a few minutes to double check your warm-up if you already did it, or do it if you haven't done it yet. So I'll give you 3 or so minutes to work on that. Alrighty, let's check it out. Number 1, 6 pi. Number 2, you got -1 over root 3, but you had to rationalize. You can't have that. We just did that, so you knew that. So negative root 3 over 3 would be your final answer for that one. Number 3, you had square root of 3, and 4, you can't have 0 on the bottom. We don't know. We can't do that. No one can do that. Divide by 0? What? That's undefined. Are we okay with all those? Are there any that I need to talk through? It's mostly just multiplying top and bottom by the reciprocal of the denominator to get it to not be a complex fraction. It's crazy. Are we okay? All right, moving forward. Going to flip to this. All right, these are our notes for today. The first thing I want you to take some time to do, I'm going to do it as well. I'm going to label with the point, like, so this is 0, it's also 2 pi, it's also 360. Do that with all the axes and make sure you put the coordinate. This is 1, 0. Once you've done that, check them out with mine, check them with your neighbors, make sure they're good. I want you to, like we did for the sine and the cosine, I want you to, thank you, we're on page 36 of the notes. I want you to draw a little triangle in there. Triangle with our angle theta. We know the hypotenuse of this triangle is 1. Wow, that was great. Yes. And this distance is some distance x. We know this distance is some distance y. So this point right here is x comma y. We know this. We already know this. This is nothing new to us. Are we okay with this? Just a picture. Sine and cosine, this should be review. So I'm going to kind of let you guide me here. Last time we wrote these, we started out with our trig ratios, right? Opposite over what? Hypotenuse. That's where we start. We understand? Remember the sine, opposite over hypotenuse. Now we know the opposite is, well, actually, the next thing we did was the hypotenuse, right? So opposite over our hypotenuse, which we know is 1. It's the unit circle. We also know the opposite of this angle in this little triangle right here is y. That's our y distance up. So we have y over 1. This is just review, guys. We already did this. This should just be. And just to establish sine and cosine one more time, because it all relates to tangent, which is what's coming at you. That's brand new. So we know the sine of theta is the y coordinate. Can someone talk me through cosine? Maybe even just give me the first step. Yep, that's where we start. Adjacent over hypotenuse. Thank you. We know that hypotenuse again is just 1. Good. Adjacent to this angle right here is our x. Adjacent to any angle near the x-axis will be the x distance, right? We did that with our investigation where we moved those triangles around. this was always the x distance, and it was also always adjacent to our angle right here, no matter what quadrant. So we know we can replace that with x, adjacent with x. And x over 1, that's just x. So once again, we've established that the cosine is the x coordinate. Now, tangent. All right, well, we know the trig ratio for tangent. Let's just look at this triangle without the circle. All right, we have an angle. We're trying to find the tangent of that angle. What do we write? Tangent of the angle equals what over what? Yes, exactly. Tangent of that angle is just opposite over adjacent. We knew that. Okay, so now let's maybe apply it to the unit circle, to this triangle inside the unit circle. Okay, opposite. What's the opposite of this angle? That's y. Yep. And adjacent is x. Okay. But what do we also know about y and x from up here? What do they also equal? Sine and cosine. Look at this. Tangent of theta is sine over cosine. We can make it official, write it next to it. So when we are asked tangent of an angle on the unit circle, we're going to need to know the sine and the cosine. So it's not any new information. It's just remembering that this is how to find it. We know the sine and the cosine because you know the coordinates. I know that from the quizzes yesterday because you guys did really well. So I would say here, when you're finding the tangent of an angle, it gets kind of messy, kind of like the warm-up. Those are kind of like a preview of what your answers are going to be and how you're going to have to simplify them. So if you are struggling, I wrote before, go back to the radical review if you're having a hard time, because that's why we did it. That's why we had the radical review, so that you could make sure you could simplify and rationalize, all that good stuff. And that's where it comes into play, is when we're finding the tangent. So if you find that you're having a hard time simplifying, go back to that radical review. It'll help you, I promise. Are we okay with how we got tangent? It's brand new, but we all see it. We all see opposite over adjacent, just y over x, but we know it's sine over cosine. I see confusion. Are we okay? Yeah? Okay. All right, let's do two together. So I'm going to take baby steps. Eventually, you don't have to, but just to start out, obviously, it's nice. So I'm going to start out by writing sine of 30 over cosine of 30. We just established this. The tangent of an angle is sine of that angle over cosine of that angle. That's the same thing. All right, well, let's do some scratch work, because we know what those values are. Sine of 30, what is that? I'll give you a second, but you know it. Sine of 30, think about it. Yeah, go ahead. 1/2, you are correct. All right, and someone else for the cosine of 30? Square root of 3 over 2. Good. Okay, so we know what sine and cosine equal. Let's plug them in. All right, sine of 30, 1/2, all over cosine of 30, square root of 3 over 2. Are we seeing where our warm-up comes into play and the radical review comes into play? We have to clean this up. So to get rid of all these crazy fractions, I'm going to multiply top and bottom by the reciprocal of this. So 2 over root 3. 2 over root 3. Do you see what I did there? That's just a factor of 1. This is like 4 over 4. It's just 1, right? We're multiplying by a factor of 1. But we did it so that things would cancel, right? This is like a factor of 1. This is like a factor of 1. Our whole denominator now is 1. What we are left with is 1/2 times 2 over root 3. The 2's simplify. That's another factor of 1. So when multiplying fractions, we go straight across. 1 over root 3. Is that my answer? Can I box that? No, 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 no. Yes, we have to rationalize. Multiply by a factor of 1. Root 3 over root 3. Multiply across. We have root 3 on the top. Multiply across the bottom. What's left on the bottom, Billy? 3. Exactly. Good. That is our final answer. The tangent of 30 degrees is root 3 over 3. It seems like we're a long distance from where we started, but it honestly gets very quick. As you practice these, you see it quicker. It just happens. Yes. What is used for? You mean the tangent? No, it's okay. Tangent is just another relationship with triangles. So you told me I understand sine and cosine. That's the relationship between sine is the relationship between the opposite side and the hypotenuse. And the cosine is the adjacent with the hypotenuse. And tangent is just another way to look at that triangle. And we're just applying it to our unit circle. So it's not an x or y, but it is y over x. Yeah. So are we okay with part A? Yeah? All right, let's try part B. This is a little bit easier. Yeah. Oh, no, you're okay? Okay. So we have sine of 45 degrees, cosine of 45 degrees. Yeah. It would just be 1. I'll write it out for the sake of learning and all the steps. So we have, you could immediately see that this is something over something, which is always just 1. If you don't see that right away, you could still try and get rid of all the fractions. You'll just notice that when you do it, like Michael said, everything turns to 1. So your answer there is 1. Do we see that? If you see that, I do want you to try C and D. In your packets is C, D, E, and F, say cosine. Scratch that out, right? Tangent. Well, being that it's in the section with tangent. But yeah, I would like you to try C and D on your own. If you're feeling comfortable, move on to E and F. If you're not, stop and I will do them on the board. Oh. So that first one is 1. D, what did we get? Anyone? It's not root 3. 1 root 3 over 3. Yes. So, so that's just root 3 over 3. For this one, you would have had the sine of 7 pi over 6, which is negative 1/2, over the cosine of 7 pi over 6, which is negative root 3 over 2. When you're multiplying, you have to multiply by the reciprocal. So you have to have the negative also, because the negatives have to cancel as well. Or else you won't have it over 1, you'll have it over negative 1. So make sure you carry through the negative. So we have everything in the denominator canceling out to be 1. In the top, our 2's cancel out. We have a negative times a negative. That's just a positive. So we have 1 over root 3. Jonathan, do you see where you may have? Oh, yeah, that'll get you. All right, so then we have to rationalize, and that's where we get our final answer. Are we okay with both of those? If you're okay with both of those, you can work with a partner and finish E and F, and then you have some conclusion questions that need to be completed. The conclusion questions are super important. If you can answer them, that means you understand the material for today. So take some time, finish the last two as independent practice. I can come around and check and make sure you did them right to make sure you're on the right track. And then the conclusion questions. Your homework, heads up, your homework for tonight, that's 39 and 40 in your packet. It's right after the notes. It's a worksheet. Just making sure you can do the tangent. Yes, sir. Yeah. Yeah. You okay?